In section 6.3, we look at adding and subtracting rational functions. So just as a reminder, when you add two fractions together, you can only do so if you have a common denominator. And if you do, the denominator stays the same, and you simply add the numerators together. Subtraction works the same way. You have to have a common denominator, which stays the same when you subtract, and we simply subtract the numerators. So for a few examples here, let's consider 3 over 2x plus 4 over 2x. Notice that we already have a common denominator of 2x. That means our answer will have that same denominator. And all we need to do is add the numerators 3 plus 4. And this, of course, gives us 7 over 2x. For the next example, very similar. We want to add the fractions x over 8y plus x over 8y. So notice once again the denominator is the same, it's 8y. And we simply need to add the numerators. And x plus x, of course, is 2x over 8y. And one final thing we can do here is we can reduce the fraction. 2 divides into 8 4 times. And so our final answer here is x over 4y. So no matter what, always look to reduce your answer. And one more here. 19x over 3t squared minus x over 3t squared. We have a common denominator of 3t squared. And all we have to do is subtract the numerators, keeping in mind, of course, that x is the same as 1x. And so this becomes 18x over 3t squared. And then we can divide 3 into 18, which gives us a final answer of 6x over t squared. So these were all examples where we had a common denominator. If you don't have a common denominator, it involves a little bit more work. In our next couple of examples, we still have a common denominator, but notice now the denominator is made up of two terms. So the denominator in each of these is x minus 3. So because we have that common denominator, our answer will have that same denominator. And then what we need to do is subtract the numerators. And so 5x minus 15 over x minus 3. And this is the answer, but we need to consider simplifying. And so now simplifying is a little bit more involved. What we need to do here is factor out the greatest common factor in the numerator, which is 5. And that gives us 5 times the quantity x minus 3 over x minus 3. And those x minus 3's will cancel out. And if it makes you feel a little bit better, you can put parentheses around the x minus 3 in the denominator. And when those cancel out, we simply get 5. So what this is saying in this example is that no matter what value of x you plug into this expression, when you subtract these two numbers, you will always get the number 5. That is, of course, unless x equals 3, because if x equals 3, you have an undefined expression here. So the answer is 5, and then I'm just going to remind you that x cannot be equal to 3 in this problem. So always keep in mind that the denominator cannot be equal to 0. So in our next example, again, very similar. We have a common denominator of x squared minus 4. And then we need to, in this case, add the numerators. So 2x plus 8 over x squared minus 4. And then to simplify our answer, we need to factor. And so if we factor the numerator, we can take out a 2, and we get 2 times the quantity x plus 4. And in the denominator, we get x minus 2 times x plus 2. And notice that we have factored everything, but nothing cancels. So we always try to reduce our answer, but don't force your answer to reduce. Make sure that you're only canceling factors that are alike. So you need to be careful there. Okay, in the next couple of examples, we do not have a common denominator. And so in a problem where the denominators are different, we need to make the denominators equal by multiplying each fraction by the appropriate factor. So in number 6 here, the denominator of the first fraction is x plus 2. The denominator of the second fraction is x minus 4. The least common denominator, or LCD, is going to be the product of those two factors. So what we need to do to get a common denominator is we need to multiply the first fraction in the denominator by x minus 4. But whatever you multiply to the denominator, you have to multiply by the same thing to the numerator. And in the second fraction, we're going to multiply by x plus 2 to the denominator. And of course, whatever you do to the denominator, you must do the same thing to the numerator. And it's really important here that you consider putting parentheses around all of these binomial factors. Now, the next step is important. What we're going to do next is rewrite each of these two fractions. Keep in the denominator in factored form. And so the denominator here is x minus 4 times x plus 2. There's no need to multiply that out. The denominator here is also x minus 4 times x plus 2. But we are going to multiply out the numerator. So when we do the multiplication on top, we're going to distribute the 5 to each of those. And when we do that, we get 5x minus 20. Likewise, for the second fraction, we're going to distribute the 3 to each of those, which gives us 3x plus 6. And see, now we can add the numerators. You want the terms exposed in the numerator, because when you add them together, you want to combine like terms. So that's why we don't want to have parentheses in the numerator. So adding these together, our next fraction is going to have that common denominator. And we have 5x minus 20 plus 3x plus 6. And when you combine like terms in the numerator, 5x plus 3x is 8x. Negative 20 plus 6 is negative 14, and that's over x minus 4 times x plus 2. And now the question is, can you simplify the fraction? Well, the answer is no. So I'm going to box the answer here, but I'm going to show you why the answer is no. If you factor the numerator, you can pull out a greatest common factor of 2. And if you take that out, you get 2 times 4x minus 7. Now this answer is acceptable, but notice that once again, there are no factors here that can cancel each other out. So your answer is fine in either format. So my suggestion is that if you can see in this answer that it's not going to cancel when you factor, then there's no reason to factor your answer. In fact, sometimes you'll see the answer expressed completely multiplied out. And so we'll have 8x minus 14 in the numerator. And if you multiply these two factors together, you get x squared minus 2x minus 8. And so this is yet another way to express the answer. I want you to understand that all are correct. I think the first expression of the answer is the best. That's my personal opinion. And the reason I have that opinion is I like the denominator to be in factored form. Because when it's in factored form, I can still see that x cannot equal positive 4, and x also cannot equal negative 2. In problem number 7, it's essentially the same idea. So we have two fractions. The denominators here are different. So I'm going to rewrite the problem. And I need to multiply. The first fraction needs to be multiplied by x minus 2. So notice that I'm multiplying the first fraction by the denominator of the other fraction. And in the second fraction, we're going to multiply it by the denominator of the first fraction. And I'm going to do this in one step here. I'm going to multiply this out in the numerator on each of those. And so that gives us 2x squared minus 4x over the denominator, which I am not going to multiply out. Then we have minus, and then here when I distribute, I'm only multiplying the 3 to each of these, not the negative. So it's 3x plus 15 over x minus 2, x plus 5. And now from here, you can see we have a common denominator. That's good. That means we're going to have that same denominator in our answer. And what we need to do is subtract the numerators. So we take the first numerator, and when you subtract the second numerator, you have to distribute this negative sign to each one of those terms. So this is a critical step. This becomes minus 3x and minus 15. So it's really important that you see to distribute that negative sign. Now we can go ahead and simplify. Denominator is the same. In the numerator, we're going to combine like terms. So negative 4x and negative 3x make negative 7x. And then finally, we need to try to simplify. So, it could be that this is the answer. The question is, does it simplify? Well, to simplify it, we have to factor the numerator. And so that gets back to our trinomial factoring. Now, some of you I know, once again, you're already good at this, and so you don't need to do what I am about to do. But for many of us who struggle, remember to factor a trinomial, a quadratic like this, we're going to multiply 2 times negative 15, which is negative 30. We're going to write down the middle number there, which is negative 7. And the two numbers that multiply to give you negative 30 and add to give you negative 7 are negative 10 and 3. And that means that the factorization here is x minus 10 divided by the leading coefficient, which is 2, and the other factor is x plus 3 divided by the leading coefficient, which is 2. And remember how this goes. And so what we do next is simplify. So we have x minus 5, and then x plus 3 halves doesn't simplify. And remember, what we do in this case is we take the 2 and we sneak it in front of the x there. And so this becomes x minus 5 times 2x plus 3. And so that is the factorization of this numerator up here. And so this becomes x minus 5 times 2x plus 3 over x minus 2 times x plus 5. And you can kind of see now that that was sort of a waste of time, wasn't it? Because the only reason we want to factor here is that maybe we could cancel something. But see, x minus 5 and x plus 5 are different. So there's nothing that cancels there. But, you know, the thing is, you're not going to know that until you actually factor. So now that we know this, we can see that it would have been okay to just leave our answer like this. Both of these would be okay. But again, if your answer would have simplified, then the original answer would not be okay. You need to give the simplified answer anytime possible. Okay, so for our next 3 problems, it's more of the same stuff here. Problem number 8 is sometimes confusing for students. It's really not too difficult of a problem. What you need to do is remember that a number like 5 can always be expressed as 5 over 1. And then when you write it that way, you can see that the least common denominator for this problem is x plus 1. And so that means we need to multiply the first fraction by x plus 1, top and bottom. And the second fraction we don't need to multiply by anything because we already have x plus 1. So then we distribute, which gives us 5x plus 5 over x plus 1 minus 3 over x plus 1. Now we have a common denominator, and all we have to do is subtract 5x plus 5 minus 3, which gives us 5x plus 2. And so our answer is 5x plus 2 over x plus 1. So when you have a whole number being added or subtracted with a fraction, you just need to turn that whole number into a fraction. Next problem, a little bit different. What we have here is a denominator that needs to be factored. It's difficult to see what the least common denominator is until you factor this polynomial. And so the first fraction is 2 over x minus 2. And the second fraction is 3 over. And then when you do the factorization, you should end up with x plus 3 times x minus 2. And so the denominators are not the same, clearly. But the nice thing is that the denominators do have one factor in common already. So what I need is to multiply by x plus 3 over here. So I'm going to multiply by x plus 3 over x plus 3. Distribute the numerator. That gives us 2x plus 6 over x plus 3 times x minus 2 plus 3 over x plus 3 times x minus 2. And now if we add those together, we have our common denominator, and the numerator will be 2x plus 6 plus 3 is plus 9. And that is our final answer. 2x plus 9 does not factor. Okay, so for number 10 here, you can see that these two denominators are clearly different. Now, you certainly don't want to multiply these denominators by each other. So the first step here is you need to factor each of those denominators. And the factoring is relatively simple. So I'm just going to write it down here. Obviously, I know some of you will factor this as quickly as I did, and some of you will need more time to factor. But this is what you should end up with when you factor it. So the denominators, again, are clearly different, but they do have a plus 2 in common. So we only need to multiply each of the denominators by what it is missing compared to the other denominator. So this denominator is missing the factor a plus 1. So I need to multiply this fraction by a plus 1, top and bottom. And this fraction here is missing the factor a plus 3. So we need to multiply by a plus 3, top and bottom. After that, multiply out the numerators. Leave the denominator factored. So the denominator of the first fraction is this. The denominator of the second fraction is the same, of course, because that's the whole point. And then when you do the multiplication in the numerator, a times a is a squared, plus 1 times a is a. And then here, 2 times a is 2a, and 2 times 3 is positive 6. And so now we have a common denominator, but it is subtraction. And you always have to be more careful with subtraction, because that subtraction needs to distribute to each one of those terms. So in the end here, we end up with the common denominator, and the numerator is a squared plus a minus 2a minus 6. And then we just have to simplify. And so the numerator, if you combine like terms, you end up with a squared minus a minus 6. And this is essentially our answer. But we have to check to see if we can reduce it. And so, can we factor this? The answer is yes. And if you do, you get a minus 3 times a plus 2 over the common denominator. And this time you can see this was not a waste of time, because clearly we have a common factor here with the a plus 2. So we can go ahead and cancel that out. And we end up with a minus 3 in the numerator and a plus 1 times a plus 3 in the denominator. All right, so that's a pretty good problem, pretty involved. But it really is just a matter of factoring correctly and being very careful. You have to be meticulous. If you make one mistake, with a positive sign or a negative sign or parentheses, then you're not going to get the problem right. Moving on to section 6.4, this will be a very short section. In fact, I'm only planning to do these 2 examples that you see. We're looking at simplifying complex fractions. So first of all, what does it mean to have a complex fraction? Basically, it means that you have little fractions inside of a larger fraction. And so what we want to do is simplify that by turning the complex fraction into a simple fraction. So what we're trying to do is convert our complex fraction into a simple fraction, which just means a regular fraction. So we want our answer to look something like this, a over b. Now, there are a couple of different ways to do this, but there is by far one method that is easier than all the others. What we do is we look at all the denominators, the little denominators, all of these, and we identify that the least common denominator among those four denominators, in this case, is x squared. Then what we're going to do is just take that complex fraction and we're going to multiply the numerator and the denominator by that least common denominator. So I'm multiplying by x squared to the large numerator and the large denominator. And then what we do is we distribute that x squared to each of these terms. And so when you do that, you get this. And the whole point is each one of those x squareds can be thought of as x squared over 1. And now what you can do when you multiply these little fractions together is you can cross-cancel common factors. So x squared cancels with x squared. Here x squared cancels with x squared. And on this one, x will cancel one of those x's. So this cancels out, takes away one of those. And down here, this x will cancel out one of those x's. And so what you have left here is 2 over 1, which is 2, plus what we have left over here is x times 1, which is x. In the denominator, we have x times 2, which is 2x, plus, and then here all we have left is 1 over 1, which is 1. And that's pretty much the answer. The only other thing I'm going to do here is just write it in descending order. And so we've taken this complex fraction and we've converted it into a simple fraction, a regular fraction. Now for our next problem, let me rewrite it down below. Okay, so for this one, same idea. First, we want to identify the common denominator, which in this case is a squared. And then I'm going to multiply the top by a squared and the bottom by a squared. And then we distribute that to each of the terms, top and bottom. And that gives us this. So I've distributed the a squared to each of the terms in the numerator and the denominator. Also, I like to write a squared over 1 because that helps see the cross-canceling. We can cross-cancel here. A goes into a squared a times. And then here there's nothing to cancel. Down below we can cancel the a squareds here. We can cancel an a there. And here there is nothing to cancel. And then you have to be careful because when you start crossing everything out, sometimes it's hard to see what's left. So what we have left over in the numerator here is 3 minus 4 times a plus a squared. And in the denominator, we have a squared minus a minus 6. And now all we have to do is simplify that answer. So now to simplify, you need to factor these polynomials. And factoring is always easier when it's in descending order. So I'm going to rewrite the numerator by putting it in descending order. And the denominator was already in descending order. And then now what we can do is factor these trinomials using the methods that we've talked about previously. And so when you do the factorization, of each of these trinomials. This is what you end up with. And then you can clearly see that we have an a minus 3 in common here. And so we can cancel those out. And our final answer here is a minus 1 over a plus 2. Okay, time to do some more homework.